A Japanese airport just settled into the seabed, sinking inches every single year while engineers race to keep it afloat with thousands of hydraulic jacks. It is a man-made island built on a soft, shifting ocean floor. That is a real project. It exists, it operates every single day, and it cost more money to build and maintain than almost any other infrastructure project in the country. But here is the thing, that airport had to earn the #1 spot on this list. We're counting down 5 of Japan's most impossible mega projects, ranked from the least to the most expensive. The competition is insane. We're talking about a record-breaking suspension bridge, a deep-sea railway tunnel, a 400-kilometer concrete wall against tsunami, and a bridge-tunnel hybrid that spans the entire bay. 5 mega projects, 5 different answers to the question, how far can you push what a nation is allowed to build? Before we get into it, if you enjoy videos like this, hit the like button right now. These take a serious amount of research and time to put together, and every like pushes this to more people who would love it. Subscribe as well so you never miss what we cover next. Some of these projects will make you question your entire definition of scale, and by the time we reach #1, you will understand why one country just rewrote the rules for an entire industry. Let's count down, starting with the least expensive of the 5. Number 5. The Akashi Kaikyō Bridge. When you look at the Akashi Kaikyō Bridge, you aren't just looking at a way to get from Kobe to Awaji Island, you are looking at a defiance of geography. Before this bridge existed, the only way to cross the Akashi Strait was by ferry. But this wasn't just a simple commute. The Akashi Strait is one of the busiest, most treacherous shipping lanes in the world. It's a narrow bottleneck where the currents reach speeds of up to 4.5 meters per second, nearly 9 knots. Imagine trying to steer a massive cargo ship through a narrow gate while the water is trying to rip your vessel away. For decades, the local communities lived in fear of the crossing. Ferries were constantly disrupted by heavy fog and the violent, churning tides. In 1955, a tragedy struck that changed everything. 2 school ferries collided in the strait during a storm, resulting in the deaths of 168 people, mostly children. It was a national trauma that left an indelible mark on the Japanese psyche. It was clear the ferry system was not just inconvenient, it was a death trap. The government decided that a bridge was the only solution, but the engineers had no idea what they were getting themselves into. The challenges were, quite frankly, absurd. First, the water is deep, over 100 meters at the center. Second, the strait is a major international shipping route, meaning you couldn't just put support pillars wherever you wanted. You had to maintain a massive central span that wouldn't block the giant container ships passing through. Third, and most importantly, this is Japan. The Akashi Strait sits right on top of a major geological fault line. When the engineers sat down to draft the initial plans, they were looking at a central span of 1,780 meters. No one had ever built a suspension bridge that long. They had to invent new steel alloys just to support the weight of the cables, which are so thick they look like solid metal pillars. To give you an idea of the scale, if you took all the steel wire used in the main cables of the Akashi Kaikyō and laid it end to end, it would circle the Earth 7 times. 7 times. But the real test came in 1995. The bridge was still under construction. The 2 main towers were standing, and they were beginning to string the cables when the Great Hanshin earthquake, the deadliest in Japan since the 1923 Kanto earthquake, struck just a few kilometers away. The epicenter was right there, in the strait. The earth literally tore itself apart. The ground shifted, the seabed liquefied, and the tectonic plates moved in a way that, according to the original blueprints, should have rendered the bridge project a total loss. When the engineers arrived at the site after the shock, they expected to find the towers collapsed or the foundations cracked. What they found instead was something that defied physics. The bridge had held, but the tectonic plates had moved so violently that the distance between the 2 main towers had actually increased by 1 meter. The entire bridge was now a meter longer than it had been the day before. This is the kind of moment that breaks a project. Most people would say, well, that's it, we need to start over. But the Japanese engineering team did something brilliant. They didn't scrap the design, they simply recalculated the entire suspension tension to accommodate the new, wider distance. They treated the earthquake not as a failure of the bridge, but as a real-world test that they had somehow passed. When the bridge finally opened in 1998, it was officially the longest suspension bridge in the world. It stands today as a testament to the idea that you don't just build against nature, you build in a way that allows the structure to breathe with it. It's a $4 billion structure, the least expensive on our list, but it bought the people of the region something money can't usually buy: the end of a nightmare. It turned a death trap into a landmark of human ingenuity. But as we move up our list, we find that the Japanese didn't just want to bridge the water, they wanted to go directly through it. Number 4. The Seikan Tunnel. If the Akashi Kaikyō Bridge was a victory over the air and the currents, the Seikan Tunnel was a war fought against the crushing weight of the ocean and the unpredictable madness of the Earth's crust. We are moving deeper now, literally. We are leaving the surface and plunging 240 meters below sea level to traverse the Tsugaru Strait, the narrow but deadly stretch of water separating the main island of Honshu from the northern island of Hokkaido. The story of the Seikan Tunnel isn't just one of engineering, it's a story of a nation's refusal to be isolated by the sea. For years, the only way to connect the railway systems of the two islands was through the ferry service. It was the same story as in the Akashi Strait, but on a much more brutal scale. The Tsugaru Strait is notorious for its severe weather and treacherous currents. In 1954, a catastrophic typhoon, the Toyomaru Typhoon, struck the region. 5 ferry boats sank in a single night. Over 1,400 people perished. It was one of the worst maritime disasters in history, and it sent a shockwave through the Japanese government. The message was clear: Japan could not rely on ships to keep its islands connected. They needed a path that the weather couldn't touch. They needed a tunnel. But the sheer ambition of the Seikan Tunnel is mind-boggling even by today's standards. We aren't talking about a short tunnel through a mountain. We are talking about a 53.85-kilometer long beast with 23.3 kilometers of it running directly under the seafloor. When it was completed in 1988, it shattered all records to become the longest undersea tunnel in the world, a title it held for decades until the Channel Tunnel connected England and France. The construction process was, for lack of a better word, a nightmare. The seabed of the Tsugaru Strait is a chaotic geological mess. It is filled with fractured, unstable volcanic rock and soft, waterlogged sediment. The engineers weren't just tunneling, they were playing a game of cat and mouse with the ocean itself. Throughout the construction, which lasted over 20 years, the tunnel was flooded by massive surges of seawater on multiple occasions. These weren't just leaks, they were high-pressure torrents that would roar into the tunnel, forcing thousands of workers to evacuate in seconds and undoing years of progress in a single night. The pressure at the bottom of the strait is immense. Every time they broke through a new section of rock, they had to be prepared for a sudden, violent eruption of seawater that could drown the tunnel completely. To fight this, the engineers had to pioneer a technique called grouting, where they pumped massive amounts of special fast-setting cement into the rock face before they drilled through it. It was a slow, agonizing process. They were essentially creating an artificial, waterproof shell inside the seabed as they moved forward meter by meter. Imagine being inside a dark, claustrophobic hole, hundreds of meters beneath the waves, hearing the ocean grind against the rock above you, knowing that a single miscalculation in the cement injection could lead to a total collapse. It took 34 human lives to complete this project. It is a sobering reminder that every great feat of infrastructure is paid for in blood, sweat, and tears. But the Seikan Tunnel is more than just a tube of concrete and steel. It is a masterclass in safety. Because it's so deep and so long, it has its own dedicated stations halfway under the sea. These aren't just for maintenance. They were built as emergency evacuation points. If a train ever stalls or catches fire in the middle of the undersea portion, there are specialized evacuation systems and dedicated escape shafts that can take passengers out of the tunnel and onto the seabed surface. The tunnel is also equipped with continuous monitoring of the rock pressure, the water seepage, and the seismic activity. It is basically a living organism that is constantly reporting its own health to engineers in Tokyo. When it finally opened, it was a triumph, but it came at a high price tag, approximately $7 billion in 1980s currency. In today's money, that figure is astronomical. Some critics at the time argued that the tunnel was a bridge to nowhere, as the ferry was cheaper and the tunnel's maintenance costs were staggering. Yet, looking back, the Seikan Tunnel changed everything. It created a seamless, reliable connection that turned the northern island of Hokkaido into a vital part of the Japanese economic machine. It proved that human beings could occupy space that was never meant for us. We don't just exist on top of the planet, we can carve our way through its very foundation. foundation. The Seikan Tunnel was the proof of concept that Japan could build anywhere and in any conditions, provided they had enough patience and enough steel. But if you think that was the peak of their ambition, just wait until you see how they decided to handle the wrath of the ocean itself. Number 3. The Tsunami Seawall. If the Seikan Tunnel was a project born of tragedy, the Tsunami Seawall is a project born of pure, unadulterated survival. After the 2011 Tohoku earthquake and the subsequent tsunami that devastated the eastern coast of Japan, the national conversation shifted from how do we grow to how do we stay. The disaster was not just a natural event, it was an existential blow that claimed nearly 20,000 lives and triggered the Fukushima nuclear crisis. In the aftermath, the Japanese government faced a question that would have paralyzed any other nation. How do you build a shield against an enemy that is fundamentally unstoppable? You cannot stop the ocean, but could you at least steer it? The result is a project of staggering scale, the Tohoku Coastline Protection Project. It is a massive, unbroken chain of concrete barriers, floodgates, and breakwaters stretching over 400 kilometers along the northern Pacific coast of Honshu. We are talking about a wall that stands up to 12 meters, nearly 40 feet high in some places. When you stand at the base of this wall, you feel absolutely insignificant. It isn't just one continuous barrier. It's a complex, multi-layered defensive system designed to act as a series of speed bumps for one of the most powerful forces on Earth. The engineering required to pull this off was unprecedented. You aren't just pouring concrete, you are anchoring a structure into a coast that was physically reshaped by the 2011 earthquake. The seabed itself had dropped in several places, and the soil was unstable, saturated with silt and debris. The project required millions of tons of steel and concrete, but more importantly, it required a shift in architectural philosophy. The goal wasn't to build a wall that would be perfectly rigid and never move. It had to be a wall that could withstand the sheer hydraulic hammer of a tsunami wave, which brings with it not just water, but tons of debris, cars, houses, boats, and uprooted trees, all acting like giant projectiles. The cost for this massive undertaking is estimated at over $10 billion. It is a price tag that has sparked intense debate. Many locals living in the affected towns felt that the wall was a prison of concrete, cutting them off from the ocean that had sustained their families for centuries. Fishermen complained that the wall prevented them from seeing the sea, and tourists avoided the once beautiful vistas, now dominated by gray industrial barriers. It is a poignant, painful intersection of safety versus heritage. The government argued that the wall would buy time, crucial, life-saving minutes during an emergency, to allow residents to reach higher ground. But the engineers faced a darker reality. They knew, deep down, that while a 12-meter wall might stop a moderate tsunami, there is always the potential for a mega event that could overtop anything humans are willing to build. The wall is integrated with sophisticated automated floodgate systems. Some of these gates are massive steel monoliths that can be deployed in minutes, controlled by satellite links and seismic sensors. As soon as an earthquake is detected, the command center in Tokyo can trigger a synchronized closure of these gates across hundreds of kilometers of coastline. It's a digital nervous system controlling a physical, brute force defense. During the construction, they had to contend with the radioactive fallout zone near Fukushima, which added an entire layer of logistical complexity that no civil engineering firm had ever dealt with before. Teams had to work in specialized gear, ensuring that the heavy machinery wasn't just moving earth, but was also carefully managing the contaminated material beneath it. What makes this project truly haunting is its permanence. This wall isn't a temporary solution. It is a permanent change to the Japanese landscape. It is the nation's way of marking its territory against the Pacific. It's an admission that the world has changed and that the risk of living by the sea has increased. Critics call it a monument to anxiety, but for the people who survived the 2011 disaster, it represents a promise that the state will do everything in its power to prevent another total catastrophe. It is an engineering project that serves as a psychological anchor. But as we look at this wall, we have to recognize the limits of our own hubris. We have built a barrier that stretches the length of a small country, yet it is only as strong as the next tectonic shift. The wall is a masterpiece of logistics, construction, and planning, but it is also a reminder of the fragility of civilization. It cost $10 billion to put this shield in place, and while it is the third most expensive project on our list, its value cannot be be measured in dollars. It is measured in the lives it is designed to protect. Yet, Japan didn't stop there. As they moved into the next decade, they decided to tackle one of the most difficult geography problems on the planet, crossing a bay that was literally built to be impassable. From the silent, cold concrete of the seawall, we now move to the bridge-tunnel hybrid that defies the very concept of a shoreline. Number 2. The Tokyo Bay Aqua-Line. If you ever want to understand why Japan is often called the final boss of civil engineering, you don't look at a bridge and you don't look at a tunnel. You look at the Tokyo Bay Aqua-Line. Imagine you are standing in Kawasaki, staring out across the massive expanse of Tokyo Bay. You want to get to Kisarazu on the other side. By land, it's a 100-kilometer drive around the bay, fighting some of the world's most suffocating traffic through the heart of Tokyo. It takes hours, but if you could just go across the water, it would be a 15-minute commute. The problem? Tokyo Bay is a central hub for the world's busiest maritime traffic. You can't just build a bridge, because a bridge would be a massive obstacle for the tankers and container ships coming into the port. But you also can't just build a tunnel, because the water is too deep and the mud too unstable to safely tunnel the entire distance. So, the Japanese engineers did the only logical thing. They decided to build both. And then, they decided to connect them in the middle of the ocean. The Aqua-Line is a 14-kilometer-long engineering miracle that consists of a 4.4-kilometer bridge on the Kisarazu side and a 9.6-kilometer undersea tunnel on the Kawasaki side. But the genius and the sheer staggering cost of $11 to $12 billion lies in the Umi Hataru, the man-made island built at the precise point where the bridge meets the tunnel. This isn't just an exit ramp, it's an entire 5-story structure built on an artificial island that sits smack in the middle of the bay. It serves as a ventilation tower for the tunnel, a tourist destination, and a rest stop that feels like a cruise ship permanently anchored in the middle of the ocean. Constructing this island was a feat of logistics that defied all previous methods. To create a foundation for Umi Hataru, they had to sink a massive steel caisson, a giant, hollow, cylindrical structure, into the seabed. But because the seabed was soft, silty sludge, the island had to be massive just to stay upright. Once the island was set, the tunnel boring machines, TBMs, had to do the impossible. They were tasked with digging the world's largest undersea road tunnel at the time, using technology that was pushed to its absolute limits. The tunnel itself is a marvel of safety and design. Because it sits under one of the world's most active shipping lanes, it had to be buried deep into the seabed to ensure no dragging ship anchor could ever pierce it. To drill through such soft, unstable earth while keeping the tunnel watertight was a constant battle against geological collapse. The TBMs were so large that they had to be disassembled, moved, and reassembled in ways that had never been attempted. And remember, they were doing this in a bay that is prone to earthquakes and typhoons. The entire structure is designed to be seismically isolated, meaning it can flex, twist, and absorb the energy of an earthquake without shattering. But the real magic of the Aqua-Line isn't just the steel and concrete, it's the experience of using it. You start on the bridge, soaring above the waves with a panoramic view of the Tokyo skyline, and then, without warning, you descend into the Umi Hotaru Island, disappear into the mouth of the tunnel, and suddenly you are traveling 60 meters below the surface of the Pacific. It is the ultimate portal experience. It turns a miserable, multi-hour slog into a high-speed, breathtaking drive. However, the Aqua-Line's history is a cautionary tale of economic ambition. When it opened in 1997, it was criticized as a ghost road. The tolls were so high, originally over 4,000 yen, that almost no one used it. It became the poster child for Japan's wasteful infrastructure spending. The government actually had to slash the tolls by more than half just to get people to drive on it. Today, it's a vital artery, but it took years for the public to accept it. It is a reminder that even the most perfect engineering project has to justify its own existence to the people it serves. The Aqua-Line cost more than the Seikan Tunnel and the Tsunami Seawall, but it achieved something none of them did. It fundamentally changed the daily life of millions of people, turning two distant, disparate regions into a single, cohesive economic zone. It is a bridge-tunnel hybrid that refuses to choose between land and sea, forcing them to coexist. It is a bold, expensive, and iconic piece of infrastructure that screams Japan in every steel beam. It sits at number 2 on our list because, while it is breathtaking, there is one project, the one we started with, that is just too persistent, too expensive, and too audacious to be anywhere but the top spot. You've seen the bridge, the tunnel, the wall, and the hybrid. Now, we're going to the project that makes all of them look like a weekend DIY hobby. We're going to the island that simply refuses to sink, no matter how much money Japan pours into its foundations. We're going to Kansai. Number 1. The Kansai International Airport. We started this journey with a single question. How far can you push what a nation is allowed to build? We've looked at bridges that defy earthquakes, tunnels that dive into the Earth's crust, barriers that tame the ocean, and hybrid roads that sit in the middle of the sea. But all of those projects, as impossible as they seem, are built on something relatively stable. They are anchored into the bedrock or the earth. But our number 1 project, it was built on a foundation of pure, liquid uncertainty. It is not just an airport, it is an island that literally wasn't there 40 years ago. It is the Kansai International Airport, the most expensive, most obsessive, and most problematic engineering project in the history of civil aviation. The story of Kansai begins in the 1980s. Osaka, Japan's second largest city, was booming. It was the heart of the Japanese economic miracle, but it had a massive problem. There was no room to grow. The existing airport, Itami, was landlocked, surrounded by dense urban sprawl, and couldn't handle the 24-hour traffic the city's economy demanded. The government realized that if they wanted to compete globally, they needed an international hub that could run day and night without disturbing the neighbors. The solution? They looked at the blue expanse of Osaka Bay and decided to build an island 5 kilometers offshore. This wasn't just a land reclamation project. They were going to build an entire runway complex in water 18 meters deep on a seabed composed of soft alluvial clay, a material so squishy and unstable that engineers traditionally avoided it like the plague. They weren't just building on land, they were building on a giant, saturated sponge. The plan was to dump 21 million cubic meters of rock and earth into the bay to create a massive, stable platform. But the ocean had other ideas. From the moment they started dropping the fill material, the seabed began to groan. The clay beneath the weight of the new island started to compress and squirt out from underneath the edges. The island wasn't just sitting on the water, it was sinking into the mud like a heavy stone in a bowl of pudding. And it wasn't sinking evenly. The parts with more weight sank faster, and the parts with less weight stayed higher, threatening to crack the entire structure apart. The project cost ballooned to over $20 billion, and that was just for the first phase. In today's inflation-adjusted terms, you are looking at one of the most expensive infrastructure projects in human history. But the real, unending nightmare was the maintenance. When the airport opened in 1994, it was supposed to stop sinking after 6 years. 30 years later, it is still sinking. The island has settled more than 12 meters since construction began. Think about that. A 12-meter drop is equivalent to a 4-story building vanishing into the sea. To combat this, the engineers designed a system that is nothing short of science fiction. The airport terminal, a masterpiece of architecture designed by Renzo Piano, sits on over 900 massive hydraulic jacks. Every time the floor beneath the airport sinks or tilts, sensors detect the change, and the jacks automatically adjust to lift the building back to level. It is a building that literally walks on its own foundation to keep from being swallowed by the bay. Maintaining this airport is a daily battle. They have to constantly monitor the settlement rate of every single square meter of the island. They use GPS satellites and ground-based sensors to track the sinking, and every few months they have to add more fill material to keep the island above the waterline. It is a bottomless pit for the national budget. Critics have called it a money-burning machine, yet it works. It is the only place in Japan where you can fly in or out at 3 a.m. without waking up a single resident. It is a masterpiece of operational necessity. In 2018, the airport faced its ultimate test. Typhoon Jebi, the strongest storm to hit Japan in 25 years, struck Osaka. The storm surge was so powerful that it overwhelmed the seawalls, flooded the runways, and trapped 3,000 passengers in the terminal. The island, the pride of Japanese engineering, was turned into a swamp. The bridge connecting the island to the mainland was struck by a drifting tanker, cutting off the airport from the world. For a few days, the world watched and asked, "Is this it? Is the island finally gone?" But within weeks, the airport was back in operation. It was a humiliating moment, but it proved the resilience of the design. They didn't abandon the island. They rebuilt, reinforced, and reinforced again. Kansai is our number 1 because it represents the absolute peak of Japanese stubbornness. It is a project that would have been canceled by any other government on Earth. It is an engineering feat that refuses to follow the rules of physics and instead forces physics to work around it. It is a monument to the idea that if you have enough enough money, enough technology, and enough resolve, you can put a city in the middle of the ocean, even if that city demands that you feed it millions of dollars every single day just to keep its head above water. When you look at this airport, you aren't just seeing a place for planes to land, you are seeing the culmination of everything we've looked at today. It takes the lessons of the Akashi Bridge is earthquake proofing, the deep-sea tunneling tech of the Seikan, the defensive nature of the Tsunami Wall, and the hybrid ambition of the Aqua-Line, and it pushes them all to their breaking point. It is the ultimate expression of a nation that refuses to accept the limitations of its own geography. Kansai International is not just an airport, it is a declaration. It says that no matter how deep the water, no matter how soft the mud, and no matter how expensive the bill, Japan will build. And that is why, despite the sinking, despite the cost, and despite the typhoons, it remains the most iconic megaproject on the planet. It stands, or rather it floats, as the supreme example of what happens when human ambition refuses to settle for the land we were given. You've seen the 5 projects that define a nation. Now, the question goes back to you. If you had the budget, the technology, and the courage, what would you build? Because after seeing what is possible, the only real limit is your own imagination. Thanks for joining us on this countdown. Don't forget to hit that subscribe button